An unexpected tsunami on September 24, 2024, at 8:14 a.m. local time, a moderate magnitude 5.9 earthquake struck offshore of a completely uninhabited volcanic pinnacle in Japan's Izu Islands. Despite being centered at a fairly shallow depth of 9 kilometers or 5.6 miles below the top of the local seafloor, this quake was not felt by anyone due to its remote location and only modest size. And yet, all of a sudden, several nearby ocean buoys detected an irregular wave that lasted for 3 minutes and caused a buoy to rise by a little less than a meter. Suddenly, numerous alerts were sent out warning that a tsunami had been generated to people not only on Japan's Izu and Bonin Islands, but also the east coast of much of Japan, with the alert telling people to move to higher ground. Tsunami heights. As the tsunami raced towards several populated settlements at an average speed of 343 km per hour or 213 miles per hour, the wave slowly decreased in height. Yet, at 8:45 a.m. local time, a 50-centimeter high wave struck the island of Hachiyojima, home to a population of 7,200. It then went on to strike dozens of other towns, reaching numerous coastlines within a 1,609-kilometer or 1,000-mile radius of the tsunami's origin. And, of this, only areas within a 400-kilometer radius saw a measurable tsunami strike. Luckily, due to the small maximum run-up height of this tsunami, aka only 19.7 inches, no damage of any kind was reported. Yet, here is the problem. Due to this earthquake's only modest magnitude, a tsunami should not have occurred, as it was 63.1 times too small in terms of overall energy to have been expected to generate a tsunami in the traditional sense. Generally speaking, only earthquakes of magnitude 7.1 or larger generate tsunamis, while generally earthquakes with a magnitude of 7.5 or higher have the potential to generate large and destructive tsunamis. The reason for this is that the tsunami which was generated did not have a typical earthquake origin. Instead, just like the two tsunamis which Sumisujima were generated 180 kilometers to the south during October of 2023, they were both volcanic and tectonic in origin. If we look 12.3 kilometers to the south of the magnitude 5.9 quake's epicenter, there is a small 7.4-acre island pinnacle which rises 136 meters or 446 feet above the ocean surface. This peak represents the emergent summit of the Sumisujima volcano, which last erupted in 1916. However, if we zoom out you will see clear-cut evidence of a massive underwater caldera. And this caldera, which formed sometime in the last 20,000 years and may have even produced a 71.8-kilometer-long pyroclastic flow, is likely the source of our tsunami. Specifically, through a mechanism referred to as trapdoor faulting. These trapdoor faults, much like their name implies, move like a trapdoor, except one side sinks and one side rises. For these events to occur, three things are needed: a volcano with an active magma chamber, trapdoor faulting, a large caldera presumably more than 5 kilometers wide which is undergoing some form of resurgence, and a body of overlying water. At the present, molten rock is still likely slowly building in Sumisujima's underlying magma chamber, which largely forms a sill directly underneath the caldera. Thus, as magma builds unevenly, expanding more on the western section of the caldera, it places an increasing amount of strain on the overlying caldera ring faults. This pressure continues to build until suddenly the fault slips, which in the case of the October 8, 2023 event was by around 4 meters or 13.1 feet in mere seconds, generating a moderate magnitude reverse fault earthquake. However, like a trapdoor, the stresses of the magma cause the side within the caldera closest to the earthquake to rapidly rise while the opposite side of the caldera quickly falls by about the same amount. This subsequently generates uplift, and since this displaces overlying water, a tsunami is generated of a size more typical of earthquakes, at least a full 1 magnitude larger. Yesterday's event was not a unique occurrence, as the Sumisujima caldera, other recent tsunamis, has produced 5 other small tsunamis via the same mechanism between 1984 and 2018. More such events are likely to occur in the future, And I want to add that there is an increased risk of more small tsunamis being generated during the next 2 weeks in the same location due to the risk of similar or larger magnitude aftershocks. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.